All right, so I'm going to assume everybody went out and got this book. You guys are all like, you need the book. Let's go get the book. Find it somewhere. You don't necessarily need to get it at our bookstore, although that's the preference. We apparently get some small kickback out of our bookstore if you purchase it from them. But we want to talk about a couple of things. I have a video that I'll introduce you. So the author has started putting in some videos that I found that he's created. We'll introduce you to a couple of those. And we want to talk about that idea of our project again. So some of you have had a couple of days, maybe you've already come up with an idea. We need to find projects. And next week, we're going to start collecting that information. So start thinking really hard about, what do I want to do? Not with your life, just what do you want to do with this class and a project? So let's enable editing. Yes, there we go. So really, we have a couple of things in here. This idea is we're going to, what is required and how do we solve it? So we get the analysis of whatever the issue is. We also get the way that we try to solve the problem. So we come up with some kind of a solution. So if we look at it a little more linearly, we have to understand whatever that need is, the business need. And we generally talk about those in terms of some kind of a business requirement. So maybe the business requirement is we're at a college and we need to identify students who are at risk of dropping out. And we have actually purchased and went through this process trying to find out, is there common things that we know that students that drop out tend to have? And we figured out, yes, there are. And there's a whole litany of those. We purchased some software, we tweaked it, and we actually use it and try to analyze what students are most likely to drop out and not return. So we have to get that vision. What do we want it to be in the end? Well, in the end, it'd be really nice if it were a simplified system that could go out, identify students, target them, and then we would have some kind of an intervention in place. Well, all right. So we got our vision. Now we start defining that solution, who's involved. We communicate it. Finally, we build that solution. And then we have to test and make sure that it actually works. So in a lot of cases, what we'll do is we'll bring a solution online, and we may have it in parallel with an existing solution if we're upgrading one. If it's a new solution, we may put it in place, see what happens, and then we have to come up with, is it targeting the right people? Is it working? And once that is all done, then we launch the solution. But here's the key to this, is this is really all iterative. We never stop developing. If we have a product out there, we know that we're going to have to do updates and tweaks. It doesn't just suddenly magically end. Even a product like a word processor. Humans have been using words for thousands of years. We've had typewriters for hundreds of years. We've had word processors for probably 50 years. Why do we need updates? What is the reason behind those updates? If we launched one of the first computers from 1991 and it had a word processor on it, could you type a letter on it? You could, Justin. It would look very primitive compared to what we have, but we add new features and new items. So it would not have things like the database when you write a research paper that Microsoft Word now includes. It wouldn't have things like the graphic tools and those kinds of things that we're now used to. It wouldn't have the little paperclip icon. So all of this really stands behind something you're going to call the SDLC, Software Development Life Cycle. And so the life cycle is kind of an overarching process we look at, and we have a lot of different ways to get there, but this is kind of a generic model of what's going to happen. So again, here's those 6 core processes in the software development life cycle. And there's some other names you'll see for this, but we identify the problem, and more importantly, we also get some approval to do something with it. We plan and monitor it, okay? We discover the details of the problem. So we go in and we interview people, because one of the things that we interact with in this model is we interact a lot with people. Those people using the system all the time, they're the ones that really know what's going on. So we see what their needs are. So if every time a cash register teller went up to the cash register, they had to sign in. Well, we know that for security, that's not going to go in. But then they had to click into 7 different screens before they could deposit somebody's check. Are we really meeting that teller's needs? Are we looking at the needs of that individual or that station? Couldn't it be customized to maybe a teller? That's the most common thing they do. We understood the details. We looked at it. We said, okay, bless you.
Thank you.
That is the thing that we need to do. So we minimize it. We have that screen pop up first. Those kinds of simple things, the details of what's going on. So then we design it. Okay, so we've created a vision of what it's going to be, a design. Then we build, test, and integrate it. And then finally we deploy it. So it's made it through testing. No obvious bugs came up. No obvious issues arose. No giant glaring security holes popped up immediately. Now we're going to deploy it. But that doesn't mean we're always done with it. Remember, then we kind of loop back up in this all the way to the top in most cases. And then we keep analyzing our business needs. Businesses change, what our requirements are, what our needs are. When I came to college at Peru, now granted that's a long time ago, and I probably had a pet dinosaur so long ago, but, well, that's certainly interesting what I did. Yikes, what did I do there? Oh, there it is. Aha, fixed it. So when I came to Peru, our process for enrollment was significantly different. We used to have to meet and physically go all the way over to the cafeteria, and there'd be a big line, and you had paper forms, and they were putting it in a computer. They had 4 or 5 computer terminals over there, and they were clicking away as you had your card. And you'd get there, and you'd have a plan, and all of a sudden that class would be full. And we couldn't search for classes online because the only way to find a class was on this paper printed out book. And you had to get your instructor and in some cases your advisor's signatures. Now what I did discover is nobody paid attention to them as long as there was a signature there. So some of us got around that pretty quickly. But there was this whole litany of processes. Well, now that we've moved to online, we've moved to students wanting immediate access, that's not going to fly anymore. So we've went through several iterations, and you're going to see MyPSC as a continually evolving product. Now you can do it on your mobile phone a lot easier. It's still not perfect on the mobile device, but it's a lot easier to do it. And what we're finding is almost half of the students are enrolling on their phones or some kind of mobile device. What's even scarier is when you look at Blackboard and you see how many students are posting things like discussion boards and even sometimes assignments off of their phones. So that project. So a couple of things happen when we hear the word project. So most of you have had project management. So project has some special connotations from that, in that it has a defined beginning and an end. It's generally unique, and it's got some result that we can quantify usually. So we use that term here to represent some kind of a software project or a combination of software and hardware, something relating to information systems. And so we need to have some tools in place to start planning for that. So that process then, so generically we call the overall thing a software development lifecycle, but then we have a methodology or some way we're going to do it. So there's Scrum, kind of an interesting term. There's extreme programming. There's unified process. There's several others in there. You may have heard like rapid application development, prototyping. We have a lot of different names for these different methodologies of how we get that programming done. And so depending on which company you work with or which company you land a job at if you end up in this field, you may find that they use different tools or different sets. You end up at the same place. It's like everybody drives, maybe somebody drives a Ford, maybe somebody drives a Chevy. We all end up at school, but we kind of get some different pathways to get there. So one of the tools you're going to see that we use a lot now is we use this term, Agile. So Agile gives us the idea that we have agility, or we can move around inside of our project and change things rapidly. So the traditional programming models would take 5 to 7 years in some cases. Well, 20 years ago, that worked really well. So the FBI said, I need a new system for computers. We have 5 years to develop it. That works really well. The pace of innovation and change has happened so quickly now, that's no longer the case. And we need that agile ability so that we can rapidly jump and change if we need to. And it may be a change to external events. So it may be, using Peru as an example, maybe some other college comes out with some great enrollment tool that makes life easier and much quicker for students. Well, if we're locked in a model where we can't even go back and relook at that, we're going to be farther and farther behind the turn. If I'm a company selling a service or product, think about how do I change my models. Think about maybe I'm a big cab company in New York City. There's 13,000 plus cabs in New York City. So there are some fairly large companies that have thousands of cabs. They have to have software and monitoring and maintenance and all these things in their systems. Now along comes Uber and Lyft and other varieties. Has that forced them to change how they operate? Yeah. And so if they were locked in, where there's no way for them to change their operating models, then they're not going to be able to succeed. And that's true in most of them. So now we call a lot of things agile. Iterative just means we're looking at it and going over and over again. So agile you can think of as we can change fairly rapidly. Iterative means that we grow a system in little pieces. Instead of building the entire giant system, and we certainly did that with MyPSC, we built kind of the core and then keep adding on features and additions. And so there's new things all the time that we're looking at. Can we develop them? So I will say our book is really heavy on using this big chart. Again, it's the same core processes, and here we're just looking at it where development is. So in this different iterations, how many projects we break it up into iterations. And again, that's one of those things that really changes a lot depending on where you're at. So throughout the book, again, we use Rocky Mountain, Ridgeline Mountain. I will say Rocky Mountain every time, I can guarantee it. So they're a large stores. So really it's based on the idea of something like Cabela's. All right. Outdoor sporting, clothing, accessories, skiing, hiking, mountain climbing, all those good things. So they've got a mail order and a phone order. They've added stores, e-business component. Oh, sure kind of sounds like Cabela's / now Bass Pro or some of those stores that have been very popular. So they've got a catalog of products. They've got a website. And quite frankly, that looks like a template website, doesn't it? All right, but no, leave it alone. So what we're doing in this is each chapter we're going to go through a piece of this puzzle. Now, here's where it goes a little strange. What I kind of disagree with, although I see the point behind it, is the plan for each chapter, in this case, is to complete it in 6 days. The reality is this is not a 6-day process, but it gives us a time frame of saying 6 days and what steps would happen then on each day. Fair enough? So we know that every company has some kinds of issues. And so in this case, we have a problem. So we send out purchasing agents. So if you like to shop, a purchasing agent, great job. You go out, trade shows, buy stuff. But anyway, so they're all over the world and they need to order products. But we need some way to collect and track information about the suppliers and new products and somehow iterate that into our existing system. So what we're looking at is adding some additional subsystems. So a supplier information and a product information. So new products, new vendors. So we have some way to deal with those. So before we even get started, so we need to have that idea of what can we do? Do we see a problem? So we have that investigation. We have a system vision document, which we'll show you in the next one. And then we have this idea that before we can move too far, we need to find approval. Because if the core stakeholders or the CEOs or whoever it is that is our core stakeholder isn't going to have any buy-in, we're not going very far. You have just spun your wheels. So we need to get that buy-in And generally that is things like VPs, directors, executive management. Those people who can give you funding for the project. That's what we're talking about. So we met with them, the decision was reached, we said, hey, let's approve the plan, and we're going to find a budget. Great. So this might well be a document, something similar in your own project, what you're doing for this, that says, here's what our problem is, here's what our system should be able to do, and here's what our benefits are. So maybe you are looking at, I'll use Project Response because it's a fairly active local nonprofit. Project Response wants to come up with some kind of a mobile app so that employees can check in for health and safety welfare checks. Great. So similar type of thing. You would say, what's the problem? Why do I need that? System capabilities. So here we say this is kind of a generic overview of what we want. So we're not putting specifics in. We're not saying, hey, we're using a DB2 database to collect it. We're just saying this is what we're going to do. So here we're saying we're connecting via Wi-Fi and transmitting data, or we can connect via telephone. We can collect information about products. And you think, well, okay. And then what are the benefits of those? So increased timely communications, information will be correct, and in this case, expedite speed of how we get from a manufacturer's product into our catalog, into the website, and push out there. And if we look at companies like Zara, for example, that's one of the ways they have managed to be very successful in fashion, is they push out products very rapidly. You see a product advertised once, we go to Amazon, it's not available, then we're very sad. So this just breaks it out in a little more detail. Not going to read that to you. You guys are all capable of reading. But I will say there is something interesting. Connecting via telephone and transmitting data. So I see the Wi-Fi. Why would we say maybe we need this system to be able to connect via telephone? Why would we need that? So remember, these are employees that are going to trade shows all over the world. Are there places where Wi-Fi is not safe, secure, and really readily available? But in some cases, we may have telephones available or something else. So some way that we have a robust means to communicate. And then we look at what's going to happen with all of these different activities. So notice, remember, we're in 6 days. So 6 days for this part of the project. So we're going to say, what are the major areas? So we know we need 2 areas, a supplier and a product information. And so you guys are already in database, some of you in here, because I know that you don't change seats. And I watch you in here, and we're looking at, these are subsystems that would tie into a database, for example. So we also need to define each function to an iteration. So decide to do the supplier subsystem first, and plan that iteration as smaller and straightforward. And part of that, we already know what we have in place. And you guys don't yet. So the reality is with RMO, they said, hey, we have a lot of these pieces already existing. We can build a very small iteration, and we can add the supplier subsystem first. We already have suppliers in our database. We just need to add an interface to add those remotely, essentially. And then we assign blame and punishment. I mean, team members and responsibilities. So who's involved in the team? What are their responsibilities? So we need to think about then who's going to do what. And so we look at something like a work breakdown. And so from project management, this should be fairly familiar. You're breaking down a task into smaller subtasks, things you can quantify. So meet with the purchasing department manager. That'll take about 3 hours. So items that we can quantify. So anytime you see work breakdown structure or work breakdown, that means we're breaking it into small enough pieces that I can quantify what those tasks are. So think about this. If I say you've got to write a 10-page paper, can you tell me exactly how long that's going to take to write a 10-page paper? No. But if I break it down and I say you need to find 5 sources and research a topic, and then you need to create a rough draft, and then create a paper, are those small enough that you could start thinking about, I could put a number to each one of those? Yeah. And so that's what we're doing here is we're breaking it down into smaller and smaller pieces. So some of this is pretty optimistic. Code and test the GUI layer in the programs in 14 hours. Code and test the logic in 8 hours. Holy cow. These guys have super programmers on board. But it's really we're looking at what do they do. And so the other piece then is once we've broken it down into that work breakdown structure, notice now we can actually start making it a little more of in a work sequence. In other words, what things can we do in parallel? So notice here, we can design the architecture and the database in parallel. So in other words, I can, even though I think it may take 14 hours or whatever it is for this step, for each one of them, but I can do them simultaneously. And so you guys have all had operations management. This is that network design that you did in operations management. This is that. We're breaking it down into what things. So you need to think about in terms of precedence. So I can't perform the functional test, almost the last step, until everything else is done, right? So we need that precedence. So this gives us then a sequence of how we can do things. So when we're doing this for a larger company and a much bigger project, this is when we start looking at, well, maybe company A is assigned to this, and we have outsourcing. And so we can look at how we do this. So that's that idea of work sequence. We all know that we have things we have to do in a specific order. This tells us what we can do at the same time. So my crude example of this, when you get up in the morning and you take a shower, are there specific things you have to do in order? Well, whatever you're sleeping in, you probably should take off before you get in the shower because it's not going to work very well. You take a shower, you dry off. But if we had them in the wrong order, if you dried off before you went in the shower, well, there's a whole lot of things wrong with that. But there are also things that you can then do simultaneously. You can throw in a breakfast item in the microwave while you're brushing your teeth. So think about it that way. So day one, we've already figured out all that stuff in day one. Day two then, we're looking at that fact finding. How do I understand the requirements? And I'm going to talk about something here that I don't know if you may have heard it in database, you may have heard it in project management, an idea called a use case. And so we're going to look at that. And then we develop a list of classes and a class diagram. Ooh. So this is going to start looking familiar from other courses, even though we have that. So use case is really just something we have to do. So in this case, a use case is, I'm going to look at the bottom because I can't reach all the way to the top, upload a product image. So the use case is upload that product image, and then our description then just elaborates a little bit on it. So look up contact, using contact name, find contact information. Look up a product. So the use case, we build a list of things called use cases, things that we're going to do in this system. So then we can start, because the world is revolving around this idea of object-oriented systems where we have objects. Now we can say, all right, now I have some objects in there, things that are going to have attributes, or in this case, their values. So a supplier has supplier name, address, description, comments. A contact has all these attributes. So classes have attributes, if you want to think about it that. So when I start thinking about this, and from database, it starts to look like a table and the rows in a table there pretty quickly. So when we start putting those things together, and in fact, if we draw it like this, what does that look like? That looks like our database. So that's kind of how we're almost always ending up at the idea of our data is being stored in some kind of a database. And so here we're starting to identify those database components that we're going to add in there. So notice we have that line in here. And so that line is telling us, well, we have a product item, and that product item may have, so for one product item, it may have 0, it may have many pictures. Okay, so we can have multiple pictures. And here we have product items. And we could have one product item from a vendor, or we can have many. So Toyota has many cars. Same way with our contacts then for a supplier. We may have multiple contacts for a supplier. All right, so now we've scared you and it starts looking like a database. Now we go into that more in detail. So this is where we really start looking with and dealing with, in some cases, those end users, those people that are at the stage where they're actually dealing with it. We built the system, they have to deal with it. Get them involved early. What do they need? What do they want? Sometimes they'll pop up and reveal something. You have a manager who tells you what they think they need, and yet it's the workers that are actually doing that. So that's that in-depth fact finding. And then we're going to define their experience. So we can sketch out of what the screens, what the reports might look like. Now, we may have some of those predefined in our company or our software, and one of the things we want to do is maintain where we have consistency. So our app doesn't look like every screen you jump to looks like a Christmas carol, something popping out weird and different. But we know that we need a couple of things. We need to look up suppliers, enter data, look up contact information, enter and update contract information. So by talking to those people, we may find out, yep, maybe the most common thing we do really is look up suppliers. So that's where our home screen lands. Or we have some other preference. So we have some other diagrams here. So this is what they call a use case diagram. And so this just lets us know who interacts with these pieces. So we created those subsystems. And so that purchasing agent, well, they enter and update data. And they enter supplier information. But the manager only has a couple of those pieces. Bless you. Don't be getting sick in my class, Heather.
There's no getting.
You're already
We're
there. Nice of you to set up really close.
Hey, I told you.
I know. I'm going to go to the other screen and talk. So this tells us who has information to those particular attributes. And so again, when we start looking at it, we can also start branching that into the idea of that security matrix. Who can make those changes? So now we're doing a flow chart. But this flow chart looks a little different. And this flow chart says who has which responsibility in it. And so if you look, that flow chart has a start and an end, just like we've seen before. Enter supplier name, so notice that's under that purchasing agent. But then it interacts with the trade show system. So this is my person, this is my system. And so we can divide those two, what happens and what happens where. So it's another way we can do it. So this is just a draft of what that screen might look like that they're looking at. Pretty generic. We have our company logo. We have a web search. Maybe they can search on different ideas. And in fact, when I go into my PSC, it looks kind of somewhat like that, doesn't it? We can search on classes by day, date, time. So this is just a generic system. Now, when we get to our end users and they look at it and they go, well, what we really need is to be able to search by supplier something. We can add those things in. So this is just a draft of what we're going to do. We're going to hit day 4. So day 4 says, all right, we're going to look at this system, and now we need to design that database, or that schema for the database. I always like that word, schema. We're going to create a schema or a structure. So then we're kind of building that high level overview. So how is it going to interact? So are we going to interact only with a browser? Are we going to have a smartphone app? What kind of things are we going to have? What are our class diagrams? And so here's our schema. So in other words, here's our table name. So in the supplier table name, we have ID name. So we probably went through and we've looked at it. We probably haven't normalized this quite as much as we can, but we have some beginnings to it. So we have a supplier, we have a contact table. And in fact, when I look at this, there's some things I could see already that we could normalize and break into additional tables. But from that high level view, we've covered all the pieces we need to at this. So our architectural diagram then, so this is how are these all going to work. So we know we're going to have some kind of an internet server. Maybe our trade show system never had any of that before. So now we have to build that connection. We have to figure out how we're going to get browsers, how we're going to deal with security. But from a high level view, this is how we're going to operate. Here's our database down here, floating away with millions and millions of pieces of information. So this just adds, so in some cases what we're adding here, if you notice the supplier and the contact look very similar, now what we're adding is action pieces. So if you look up their supplier view adds, look up supplier, display supplier. This says get contact info. So we're adding those pieces where we're committing some action. So in other words, those are the SQL commands, if we're using SQL, that are actually going to build some of this. And then we get even more detailed. So here's our view layer. So this is the layer that people can see, and this is on the back end of what we're doing. So here we might have this all done in HTML or JavaScript, and back on the back end, this is SQL. So we're just trying to divide those pieces up and see where we need to do it. So that's a lot of stuff shoved into 4 days. Day 5, oh, well, great. We don't have everything done, and we know that. We also know that when a lot of the agile methods, we have some of this done as we're coding. So we code at the same time. Does that mean we're going to throw away some coding probably? Yeah. But does it also mean we can sometimes introduce products and solutions much, much quicker? So looking at all the details we have, day 5, we're already building this, each use case one at a time, and we're building that programming so each use case gets built, and then we integrate and see if all those pieces work together. That tends to be where we have some issues. So we even have some coding, for an example, of here's a PHP piece. So this one happens to look for suppliers and interacts with our database. Day 6 then. So remember, we talked about this being 6 days altogether. We're going to deploy that after day 6. Now, again, we want to do this as quick as possible. Is this really 6 days? Probably not, but it gives us an easy way to do it. So we're going to go in and we're going to start, create data. We're going to see if that data works, conduct tests. Well, we're going to see if we have any errors that pop up. And some of this is automated data testing. We can plug in data, test it. So we built some tools. And when we think that the testing is done, or at least we get to a point where we think it's usable, then we'll end that testing. Does that mean that the errors won't show up? The more complex a system is, the more chance you're going to have for data and issues. So if I think about something like Windows 10 when it came out many years ago. Windows 10 came out and they actually said, the programmer said, we estimate there's 60,000 plus programming errors in here, at least. But we released it because they don't even have a way to test every incarnation of computer and software that can be in. So this one again is a little fakey. So 6 days is a little fakey, but we do want some shorter ones. So if you can break it into 2, 4 week, a month-long projects, that's a little easier to manage than one where you have 2 years out. And if something needs to change, we can change that pretty quickly. So part of that idea of those iterations is breaking it down into smaller and smaller pieces. I think the key, though, is where and how do we involve all those end users? Because quite frankly, we can make a product that seems to fit our needs, but if it doesn't fit the needs of the end users, it's kind of a sad day. So this software development lifecycle is really kind of where we're headed towards. We're going to look at all these pieces over and over again. So a couple of things I want to mention So inside of chapter 1, let me slide that over into the screen here. So, nope, I don't really want you guys to see grades yet. So, assignments. Some people are at 100% already. You have to work your way down. All right, so inside of here, I'm going to record stuff, but I've also found that the author of this textbook has started writing some stuff. So I encourage you to go look at it. Now, these load weird inside of Blackboard, so I've got to figure out a better way to do them. But if you notice there, I have an RMO introduction video, and it's actually the author of the textbook, one of them, is actually narrating it. So that'll give you hopefully some additional information as we go. I'm going to go backwards. So don't forget this week you need to think about projects. We have a discussion board that you need to work on. There is an assignment. I've already got some people who have already done that. So there's 20 questions altogether. We skipped 10 and 11. So there's 20 real quick questions. There is a quiz to do, and all of that is due Sunday by 10 p.m. All right, have a great week and enjoy the snow if you happen to see that.